Okay, in this Math 2 video, we're going to be in Chapter 3. We're doing 55, 56, 61, and 64, which is in section 3.1.5. So on number 55, it says, when he was in first grade, Harvey played games with the spinners. One game he especially liked was 2 spinners and several markers that you moved around the board. And you were allowed to move your color if your color came up on both spinners. So Harvey always chose purple because that was his favorite color. What is the probability that Harvey could move his marker? Was purple the best choice? And this is probably that Harvey moves his marker calculated from a union or intersection of the events. And then if both spinners are spun, what is the probability that no one gets to move because the 2 colors are not the same? So the way you, and then sorry, part E, at least 2 ways to calculate answer. Part D was another way to solve it. The first thing you're going to have to do is actually make an area model for this. So I'm going to draw it really quickly, and then you're going to have to answer the question A through E, because for the most part, this should be a little bit obvious on what the probabilities are. So I'm going to call this spinner number 1, spinner number 2. So I'm going to put spinner, first spinner at the top, and then this spinner 2 on the side. So we have 1, 2, 3, 1, 2, 3. They don't have to be the same. It doesn't really matter as long as you understand what's going on. So green, purple, and yellow. So green is going to be quarter. This is another quarter, and yellow is a half. So green is going to be, let's see, 0.5. Yellow is going to be, 0.25, my bad. Not 0.5. Yellow is 0.5. And then purple is going to be 0.25 again. All right. And then spinner number 2, everything is a third, pretty much. That's a third, that's a third, that's a third. So it's basically a third of your circle. So what do we have? 1/3. It's going to be 0.333. 0.333 and 0.333, right? That should be about it. Yeah, we'll just do that. So for this one, this is a third, and this is a third. I'm going to convert all these into decimals. So green is going to be 0.33. Purple, or actually we can go yellow, is going to be 0.33. And purple is going to be 0.33 again. So you're going to have to multiply, right, to get the number inside the box. And then the question is, Harvey always chose purple because that was his favorite color. Was it probably that Harvey could move his marker? So remember, you can only move your marker if you get the same color twice. So what is the probability of getting purple twice? That's the question for this one. When you multiply this times that, what do you get over here? And then, is the probability that Harvey moves his marker calculated from a union or intersection of the events? Well, you want just one box, right? So where the event P for one spinner and purple for the other spinner meet, so that's technically an intersection of your events, right? Was purple the best color choice? So another way to answer this question would be to tell me who has the highest probability in terms of getting either purple, purple, yellow, yellow, or green, green. That's what you really want to know. Is picking green, green better? Is picking yellow, yellow better? Or is picking purple, purple better? And then part D, if both spinners are spun, what is the probability that no one gets to move because the 2 colors are not the same? So if these 3 are the 3 colors that you have for picking yellow, yellow, purple, purple, and green, green, what are the other possibilities? So these are the only 3 that lets you win the game or move on. But what's this plus this box plus this box plus this box plus this box? All right. Okay, and then come up with another way to actually calculate your answer to part D instead of just adding them up. Is there another way to do it instead of just doing that? And yes, there is. So please find another way. All right, 56. Just remember, you're multiplying polynomials. So you're basically drawing a box, right? You have the 3x plus 2. You have a 4x minus 5, everything that goes inside. This is your product, so it's equal to your sum, whatever is inside the box. This is part B, is the same thing. When it's squared like this, it's pretty much like two of them. So 4x minus 1, which is pretty much like this. So 4x minus 1, and minus 1, and then 4x minus 1. Okay, so that should be this one right here. All right, it's not 16x minus 2. That's not how this is going to go. Or 16x minus 1. All right, and then this one is actually asking you to solve. So we're going to have to do a little bit of legwork here. So this one right here looks like this. You have x plus 1, and you have 2x minus 5. So you have 2x squared, you have minus 5x, you have negative 5, and then you have 2x. All right. And then this one is pretty much just this one right here, where you have 2x, and you have x plus 3. This one right here. So you have 2x squared, and you have 6x. All right. So if that's true, then I'm going to rewrite this as 2x squared plus 6x equals, and then this one converts to this one, is 2x squared, negative 5x plus a 2x gives us negative 3x, and then minus 5. All right, well, we're going to have to solve now. So combine like terms. I have a 6x and a 3x, so I'm just going to add 3x to both sides. And that leaves us with 2x squared plus 9x equals 2x squared minus 5. And I have 2x squared and 2x squared, right? 2x squared. I'm going to subtract 2x squared from both sides because I don't really... And then we have 9x equals 5, or sorry, negative 5, my bad. Then divide by 9 on both sides, you get x equals negative 5/9. Done. All right. That was part C. And then part D looks like this, except we have to clean this up too. This is a little bit more intensive over here. We have this one, right? And I'm going to do a box for this one really quickly. So this is the same as x plus 1 times x plus 1 equals, and then there's two of these ones, so x plus 2 times x plus 2, and then we have plus 3 squared, or pretty much just plus 9. Well, if I do a box for x plus 1 and x plus 1, I guess I could do it over here, x plus 1 and x plus 1. I get x squared plus 1x plus 1x plus 1. So I get 9 plus, that's just from the 3 squared. X plus 1 and x plus 1 is over here on the side. So I have x squared plus 2x plus 1 equals. And if I do a box for 2x squared and 2x squared, x plus 2, x plus 2, I have x squared, 2x, 2x, 4. Then I get x squared plus 4x plus 4. Now I can actually combine like terms. So let's see. We have a 9 and a 1 together. So we have x squared plus 2x plus 10 equals x squared plus 4x plus 4. We're going to subtract, I don't know, let's see, subtract 2x from both sides. So we have x squared plus 10 equals x squared plus 6x. Oh my god, that's so silly. 4x plus, no, 2. Oh, that was even off. 2x plus 4. Oh, x squared. Duh. Okay, so we have 10 equals 2x plus 4. And I'm pretty sure you can figure out what x value is from there. Okay. So that was part C and part D. And then now moving on to number 61. So that's where we want to get to, expected value for the game. So I'm going to set it up, but you should probably have a better idea how to do this by now. So we have 135. So we're going to say 135 over 360. This is a 90-degree angle, so we're saying 9 over 360. And then if that's 135, that's 90. Together, everything should be 360. So I'm missing 90 plus 135 is 225. So 360 minus 225 is 100. So this is 135 degrees also out of 360. So your setup should look like, okay, expected value is equal to 90 over 360 times $5 plus 135 out of 360 times $20 plus 135 times 360 times $0. Okay, so work all those calculations out and get an expected value. And the question is, if this is how much it actually costs you per game to play, if you actually had to pay $10, would it be a fair game? Would you come out ahead? Would you come out losing money? Would you come out gaining money? Because technically a fair game means that you don't win any money and you don't lose any money. So you technically come out even. All right. So if it actually costs you $10 to play and this is your expected value, do you really want to play the game? Okay, 64, last one. Write the equation of an exponential function. Okay, so we got 0, 1, 2, 3, 4, 5. Okay, so we have 2 is at 48 and 5 is at 750. So we're going to have to divide it and then take the 1, so times. So we're going to have to take the third root because we're going down 3 times to multiply. So remember your exponential function, a times b to the x when you're doing this. So let's see, 750 divided by 48. 750 divided by 48 is 15.625. So I'm going to take the 1, 2, 3, the third root of 15.625, and that should be, I gotta find it on here. How do you do roots on this thing? Oh, there it is. The third root of 15.625. Ooh, so that gives you 2.5. Okay, so that means if you multiply this by 2.5, multiply this by 2.5, multiply this by 2.5, you should actually get 750 after 3 multiplications. So now we got to go backwards because I have to find the 0 up here. So 48 divided by 2.5 gives me 19.2 divided by 2.5 because I'm going backwards, 7.68. Yay. Okay. So final answer should be y equals 7.68 because that was our auxiliary 0 value, or your y-intercept is 7.68, and you multiply everything by 2.5, and it's an exponential. So we are finished. Hopefully you've gotten better at mastering exponential functions, ideally by this point, since we've done like 10 of them so far for homework. All right, I'll see you guys later.